hypothesized as the causative agents of several neurodegenerative diseases. Prion diseases are unusual because they appear to be caused by an infectious protein. The proposed mechanism of the disease is that the infectious protein catalyzes a conformational change in a normal protein so that it becomes the same as the infectious protein. According to the proposed mechanism, the normal protein is found in neurons in the PRPC conformation. In this conformation, the protein is harmless. The infectious protein conformation, PRPSC, is introduced to the neuron after the individual comes into contact with it in their food, or in rare cases from contact with bodily fluid of an infected individual. There are also some inherited cases where it appears that the PRPC can convert spontaneously to the PRPSC form at a low rate. However, the PRPSC form gets into the neuron. Once it is there, it contacts a PRPC protein and catalyzes its conversion to the PRPSC form. Once it is converted, it too can act to convert other protein molecules from the PRPC form to the PRPSC form. Over time, all of the PRPC proteins will be converted to the PRPSC form. Some PRPSC proteins are excreted from the cell and thus are able to spread to and infect other cells. PRPSC proteins accumulate to high levels over time. They are deposited as dense aggregates that are thought to be responsible for disease symptoms affecting the nervous system.
Dr. Prusner coined the term prion to denote a protein infectious particle. Now we know that normal prion proteins are abundant in the body and are found in the membranes of many cells, including neurons. As with other proteins, they're produced in the endoplasmic reticulum, processed in the Golgi apparatus, and transported to the cell surface. And as with many other surface-bound proteins, they're engulfed by endocytosis and degraded within lysosomes. The normal cellular prion proteins are designated by the term PRPC. The three-dimensional structure of these proteins is predominantly made up of alpha helical configurations. In prion diseases, that configuration changes to become predominantly beta-pleated sheets. The abnormally folded prion molecule is designated PRPSC because it was first identified in scrapie-infected sheep. An abnormal prion molecule can induce other normal prion proteins to adopt the pathologic configuration, thus leading to a geometric increase in the number of abnormally folded prions. These molecules aggregate together. They're resistant to proteolytic digestion, and so they can accumulate within lysosomes or on the surfaces of the cells. They're also deposited in the extracellular space and can be stained with an immunostain using an antibody directed against the prion protein. In this section, the brown areas represent deposits of prion protein in a patient's brain.
That protein, when it accumulates, is what causes the disease. The malfunction of the nervous system is really the result of PRPSC accumulation.